In this lecture, we will learn about the monoalphabetic cipher and how to implement it in Python. With the monoalphabetic cipher, each letter is substituted with a different letter in the alphabet. Only the people that have the key that maps the ciphertext letters to the real letters can decrypt the message. Let's learn how to implement the monoalphabetic cipher using Python code. At the top of the program, we will type from string import ASCII letters and digits. Then we will type from random import shuffle. After that, we will write a function that will be responsible for randomly mapping letters and numbers to other letters and numbers that will be used as ciphertext. Let's create a function named random monoalphabetic cipher. It will take in one parameter named pool, assigned a default value of none. If pool is none, we will set pool equal to ASCII letters plus digits. Then we will create a variable named original pool and set it equal to a list with the pool elements. After that will come a variable named shuffled pool, set to a list of the pool elements. Then we will call the shuffle function and pass in shuffled pool. This will mix up the order of the letters and numbers in that list, scrambling them. Now we want to create a dictionary that maps the original letters and numbers to the scrambled letters and numbers for our cipher. We will return a dictionary by zipping the original pool and shuffled pool so that each letter and number in the original pool corresponds to a letter and number from the shuffled pool, forming the key value pairs. Then we will create a function named inverse monoalphabetic cipher. This function will be used to decrypt the monoalphabetic cipher. It will take in one parameter named cipher. Inside of this function, we will create a variable named inverse monoalpha and set it equal to an empty dictionary. Then we will have a for loop for key, value in cipher.items. Inside of the for loop, we will set the key to the value and vice versa, reversing the monoalphabetic cipher. Outside of the for loop, we will return inverse monoalpha. Next, we will create a function named encrypt with monoalphabetic cipher. This function will take in two parameters, message and cipher. Inside of this function, we will create a variable named encrypted message, which we will set equal to an empty list. Then we will have a for loop for letter and message. Inside of the loop, we will append the letter from the ciphertext to the encrypted message. Outside of the for loop, we will return the encrypted characters joined together. After that, we will create a function named decrypt with monoalphabetic cipher. It will take in two parameters, encrypted message and monoalpha cipher. Inside of this function, we will return a call to encrypt with monoalphabetic cipher, with encrypted message passed in as the first argument, and a call to inverse monoalphabetic cipher passed in as the second argument, with monoalpha cipher passed into the function. Time to test our code. We will create a variable named cipher and set it equal to a call to random monoalphabetic cipher. Then we will print out cipher using Python's print function. This will generate the letter-to-letter mapping randomly and then show us the mapping. After that, we will create a variable named encrypted, which will store the encrypted message. We will set it equal to a call to the encrypt with monoalphabetic cipher function and pass in the string hello world as the first argument and cipher as the second argument. Then we will have a variable decrypted, which will store the decrypted message. We will set this equal to a call to the decrypt with monoalphabetic cipher function and pass in encrypted as the first argument and cipher as the second argument. Finally, we will print encrypted and decrypted using Python's print function. When we run the code, notice that the cipher mapping each letter to a different letter was printed out. Then we see hello world encrypted in ciphertext, and then successfully decrypted thanks to our decrypt with monoalphabetic cipher function. In the next lecture, we will learn about the Vignir cipher and how to implement it in Python.